Here. Today we're going to be doing Unit 3, Notes 3. So we are going to be talking about multiplying monomials. So the first thing we need to do is actually identify what a monomial is. So a monomial is a number, a variable, or a product of numbers and or more variables. Now remember, variables are just basically the letters that we have. Monomials that are all real numbers are called constants. Now that's something we talked about in the first note video of this unit. So you actually don't have to write anything down from this chart, but it's just there as a visual to give you some idea of what constants look like. They're just numbers. Variables, they're just letters, or you could have a product of all of them. Now remember that any of the letters could be raised to an exponent, and that's okay too. Okay, so let's go ahead and let's take a look at some of these rules of exponents. So these are really going to come into play for the rest of this unit, so please make sure you have them written down so you can always check back if you need to. So the first rule is the product of powers. So the rule is that you're going to add the exponents. Well, add the exponents. What does that mean? So if you have the same base, again, you have to have the same base, you're going to add the exponents. So when I'm multiplying a times 6, or a to the 6 times a to the third, I'm going to add the exponent. So it's going to stay a, and then it's going to be raised to the 9th power. So a to the 6 times a to the third is going to be a to the 9th. Taking a look at the next rule, that's if you take a power of a power. So if you take a power of a power, you're going to multiply the exponents. So what does that look like? If I have something like 6a to the 6. Now here's what students always forget. Coefficients, constants, all of those numbers have an exponent of 1. So I have 6a to the 6. So I'm going to take this power of 2 and I'm going to multiply each of those powers of 2 by that number. So 6 to the 1 times 2 is 2. 6 to the 2 times 2 is 12. Now with the numbers to take 6 to the second power is going to be 36. We always want to simplify out the numbers. 6 squared is the same as 6 times 6, so that becomes 36, and then we have a to the 12. Let's go ahead and let's take a look at that last rule. If anything is going to be raised to the 0 power, whatever part is being raised to the 0 power is going to be equal to 1. So for example, this whole thing that's in there, all of that is raised to 0 power, which means it's equal to 1. No matter how big the number is in there, it's going to be equal to 1. So let's take a look. What are our rules for simplified monomials? So this is kind of like your checklist as you're going through. Am I done with this problem? Well, you need to make sure all of the following are true. First, that each base appears exactly once and only once. Second, that there are no powers of powers, so you're not taking and raising something to another exponent. You need to completely get rid of that by multiplying. And lastly, that all fractions are reduced or in simplest form. So you don't want to leave any unreduced fractions. And once those are true, you can completely simplify the monomial. So let's go ahead and let's take a look at number 1. So we're going to multiply these together. Now, if a letter doesn't have an exponent on it, that means that the exponent is 1. Now, here we're using that product of powers rule where we're multiplying two things of like bases. Well, there's nothing we can do with the 4 and there's nothing we can do with the y. Okay, because they don't have any other letters to be multiplied to. So those are going to stay as is. But we can take and we can multiply x to the first times x squared. When we multiply x to the first times x squared, we're going to add those exponents, which is going to give us x to the third. So this is actually our final answer for number 1. Now let's take a look at number 2. Now this is where it gets confusing. You need to multiply coefficients and add exponents. So when I have this 3 and this 2 as coefficients on the outside, I need to multiply those two. 3 times 2 is 6. Then next I'm taking x squared times x to the 4th. Now when I multiply x squared times x to the 4th, I do add those exponents and that will give me x to the 6th. Then this is the same as y to the first power. If there's no exponent, the power is 1, not 0. So I have y to the first times y to the 8th. And when I multiply those together, I add the exponents to get y to the 9th. So that's your final answer for number 6. Now, number 3 should take you all of 2 seconds. This entire term, 4xyz cubed, is all being raised to the 0 power. Since the entire thing is being raised to the 0 power, the answer is simply just 1. Now, number 4, problems like number 4 really trip students up. So if you'll notice, this part right here, this x y to the 4th, is the only part that's being raised to the 0 power. Everything else is not. So I have 6x cubed y, and then this is being raised to the 0 power, which means it's just going to be 1, but just that part. So then I'm really just multiplying this by 1, so really it's just 6x cubed y as my final answer for number 4. Let's go ahead and let's take a look at number 5. So here I'm raising powers of powers. So what I like to do when I do that is I like to go in and put in a 1 above the 4 and put in a 1 above the x so that I remember to distribute in that power. So I'm going to go ahead and distribute that in. Boop, boop, boop. So now I'm going to multiply the exponents. So 4 to the 1 times 2 is 2. X to the 1 times 2 is 2. Again, just multiplying those exponents. And y to the 2 times 2 is 4. Now, before this is fully simplified, I need to take 4 and raise it to the 2nd power. Well, 4 squared is really the same as 4 times 4, which is 16. So I have 16x squared y to the 4th. So that right there is my final answer for number 5. Now let's take a look at number 6. Again, each of these have an exponent of 1. So I'm going to take in that 4, and I'm basically multiplying each of those exponents by 4. 2 to the 1 times 4 is 4. X to the 1 times 4 is 4, and y to the 1 times 4 is 4. So the last thing I need to do is take 2 and raise it to the 4th power. Well, that's the same as 2 times 2 times 2 times 2. And when you multiply all those 2's, you end up getting 16. And then we have x to the 4th, y to the 4th. So that's my final answer for number 6. So let's take a look at number 7. So for number 7, we need to multiply these two terms together. Now when we multiply these two terms, we need to add the exponents and multiply the coefficients. Well, this x to the 6 basically has a coefficient of 1 outside. So you're taking 5 times 1, which is just 5. Then we're going to take x to the 7 and multiply it times x to the 6. So when we do that, we need to add the exponents, and that's going to be 13 when you take 7 plus 6. Taking a look at number 8, we need to multiply coefficients. So I'm taking 4 and I'm multiplying negative 7. 4 times negative 7 is negative 28. Now I need to start adding exponents. So I have a to the first. So a to the first times a squared. When you add those exponents, you're going to end up getting a to the third. Then I'm going to take b to the 6th times b to the 3rd, add those exponents, and you end up getting b to the 9th. So that's your final answer for number 8. Now problems like 9 and 10 is where it can get really tricky. You see that person that's really scared right there. So you want to start at your innermost parenthesis. So I'm going to leave 3xy to the 4th as is right now. What I'm going to do is I'm going to take this 2 and distribute it in. So I'm going to have negative 2 squared times y squared, and that's still going to be raised to the 3rd power. Now notice that when I took negative 2 squared, I put it in parentheses. If you type it in your calculator, you want to make sure you put parentheses around that negative number. That way your calculator will give you the correct response. Well, negative 2 squared is negative 2 times negative 2, which is 4. So now I have 4y squared raised to the 3rd power. Now I still have an exponent of 1 on my 4. Okay, so I'm going to keep the 3xy to the 4th as is because I need to simplify out all these powers of powers first. So 4 to the 1 times 3 is going to be 4 to the 3rd, and y to the 2 times 3 is 6. So we're getting down there, simplifying it out. So I have 3xy to the 4th, and then 4 to the 3rd power is the same as 4 times 4 times 4, which is 64, and then I have y to the 6th. So now I'm finally ready to multiply out those parentheses. So 3 times 64 is going to give me 192. Now there's nothing to multiply the x with, so that's going to stay as is. Then I have y to the 4th times y to the 6th. So when I multiply those two together, I add them and I get y to the 10th. Okay, so let's take a look at number 10. So number 10 can also get really confusing. Okay, so let's go ahead and do that one together. So first thing I'm going to do is start working on distributing in my parentheses. So I'm going to distribute in this 3, this exponent. So each of these has a 1 on it. So 1 to the 1 times 3, that's going to be to the 3rd power. This 2 is also going to have a 3rd power on it. A squared, then being raised to the 3rd power, is going to be a to the 6th. B squared, then being raised to the 3rd power, multiplying those out, you're going to get 6. So I'm just going to work on multiplying this inner part right now. Okay, so negative 4, I'm going to raise to the 2nd power, again, in parentheses, b squared, then that again is going to be raised to the 2nd power. So before I can multiply those two parentheses, I need to take care of that power. Well, I can simplify these down a little bit. That's just going to be 1. 2 to the 3rd is the same as 2 times 2 times 2, so that's going to be 8. Then I have a to the 6th, b to the 6th. So then 4 squared is going to give me 16, and then I have b squared. So again, that's being raised to the 2nd power, and that 16 has an exponent of 1 on it. So then I have 1/8, a to the 6th, b to the 6th. 16, 1 times 2, I'm going to be raising that to the 2nd power, and then I'm going to have b squared. So here I have 1/8, a to the 6th, b to the 6th. 16 squared is the same as 16 times 16, which is, whoops, hey, that's a worksheet, which is 256, b squared. So now I'm going to take 1/8 and multiply it by 256. Well, 1/8 times 256 is really just 256 divided by 8. So when you divide those out, you end up getting 32. So then we have a to the 6th. Then we're taking b to the 6th times b squared. So then you're going to add those exponents, going to give you b to the 8th. So after all of that work, that is your final answer for number 10. Now let's take a look at number 11. So we want to find the area of the square as a monomial. So the area of a square is simply equal to length times width. So all I'm doing is multiplying 4ab times 4ab. So what I'm going to do is I'm going to give each of these a's and b's an exponent of 1 so that I remember that they're there when I add them. So 4 times 4 is going to give me 16. Remember, you're always multiplying the coefficients, and now when we multiply the letters, we're going to add the exponents. A times a to the 1st times a to the 1st, add the exponents, you're going to get 2. B to the 1st times b to the 1st, add the exponents, you're going to get 2. So that right there is your final answer for number 11. So let's take a look at number 12. To get the area of a triangle, that's going to be 1/2 base times height. So that's going to be the area of a triangle. So 1/2 times the base, which is 3a to the 4th b. 1/2 3a to the 4th b times 4ab to the 5th. Now, let's go ahead and multiply this out. Any letter that doesn't have an exponent, I like to put a 1 with. So now I'm going to multiply this 1/2 times 3 times 4. So really what I could do is 3 times 4, which is 12, and then 1/2 is the same as dividing it by 2. So that's really going to end up being 6, because 3 times 4 is 12, divided by 2 is 6. And then I'm going to have a to the 4th times a to the 1st, at those exponents, and we get a to the 5th. Then I'm going to have b to the 1st times b to the 5th, and I'm going to add those exponents and get b to the 6th. So this expression right here represents the area of the triangle. So that concludes your note video for today. Thanks for listening.